So again, how does the friction affect the distance? We're going to let that be our independent variable. And we're going to look to see what happens with the distance. That's our dependent distance. D is going to depend on the friction. Before I can plug into the formula, though, I need to convert the 72 to feet per second, and my spreadsheet's set up to do that, so I might as well use my spreadsheet. So I could just say replace the 60 here, or any of those numbers, with a 72, and then I get 105.6 feet per second. And if you forgot about how we did that before, just a reminder, 72 miles per 1 hour to convert to feet per second. We got rid of miles by noting there are 5,280 feet in 1 mile, so miles goes away. And then to get rid of hours, 1 hour is 3,600 seconds. And that gets rid of hours. So if I just take 72 times 5,280 and then divide by 3,600, that's what my spreadsheet did to get this 105.6. So my formula then for the distance, it says take the speed in feet per second and square it. So 105.6 squared, I don't really need parentheses there, divided by 2 times gravity, 32.2, times F, which we don't have, so we're just going to call it F, plus the 0.02. And then to clean this up, we could do this multiplication here and maybe distribute it through, and we have to do this square up there. So calculator help on that. Sure, I can use this as a calculator. I want to know what that number is squared, so I can just go equals u second power. So 11,151.36. Let's look back at what the homework said. 11,151.36. Okay, so there's that numerator they're claiming. And then we have to figure out which is the right denominator. And here's the 0.02, but notice the parentheses are missing. Got to have those parentheses there. So let's clean this up a little bit. So I just rewrote this a little bit. I squared the numerator and got 11,151.36. In the denominator, 2 times 32.2 is 64.4, but I still have parentheses F plus 0.2. And I could distribute the 6.4 through there. So then I need to know what is, let me write this down. So I have 64.4 times F, and what is 64.4 times 0.02? Copy that correctly. 64.4 and Desmos. 64.4 times 0.02, I get 1.288. Oh, and there's the 1.288 right there without the parentheses, so I think that looks like the right one. Yeah, so here's my cleaned up formula. I squared the top. I multiplied the 2 by 32.2. It gives me 64.4, and then I multiplied that through. So here is my simplified formula. There's really not too much I can do until I know what F is. And I don't know that yet. So that's this one for me. And yours might be in a slightly different order there. Do we remember what road grade means from that prep assignment? So 0.02 is 2%, and 2% is 2 out of 100. Right, so just write that down. As far as the interpretation of G, 0.02 is, oops, 2%. If it's slang to say 0.02, the proper way to read this is to say that's the tenths, that's the hundredths, that's really 2 out of 100, 2 hundredths. And so this right here kind of answers that next question. What does a percent mean? What does 0.02 really mean? It means 2 out of 100. So I'll let you guys choose the right answer there. Which of the variables in the formula represent a constant? Okay, so we're assuming gravity is constant. So the friction can change, the distance can change, the road grade can change, and the speed can change. So those aren't constant. So I think those are right. Ooh. All right. And then the next question is based on that one. So based on the formula that we just got, we're going to check out a friction coefficient of 0.3, of 0.5, of 0.7, and 0.9 to see how the braking distance changes. And I mentioned earlier the way the friction works, the higher the friction, the better grip your tires have for stopping you. The lower the friction, that means the slipperier it is. So 0.3, that's probably like an icy, snowy road. 0.9, that's probably like a really good asphalt road with really good tires. And so I'm just going to put this into my spreadsheet because the spreadsheet can do all of these pretty quick for me. So I'll just show you how to do that. So let's see, spreadsheet is in that tab. And let's make a new sheet. And then I need to keep track of what is F and what is D. And I'm not going to do any extra cells here. I'm just going to keep this real simple. I want to look at F at 0.3, 5, 0.7, and 0.9. Given. And then it's a matter of typing in this formula correctly. So I need each of those numbers to type it. Now, I can't write a stacked fraction on a spreadsheet. So on a spreadsheet, the way I would write that would be 11,151.36. And the division on a spreadsheet is the slash, which means the denominator has to go in parentheses. Otherwise, it would get confused about what I'm dividing by. And that F right there, that's going to be that other cell where I have those numbers typed. So I have those in column A, like A2, A3, and so on for those F numbers. But this is the way we have to type it because we can't stack them. We have to use the slash with a parentheses to say this whole thing is my denominator. And so I'm just going to equals and start typing. 11,151.36 is my numerator, slash to divide, parentheses, because the denominator is complicated, 64.4, oops, 64.4, there we go, times, and the friction, I just click on the cell next to me there to get the friction number. And then add on my 1 point, what was that? 228 or 288? 288. And then close the parentheses. And in Google Sheets, if you don't close the parentheses in the right spot, Google will try to guess for you. In Excel, it'll just say, hey, you screwed this up. And it won't try and guess for you. So you got to make sure you get it right. So that looks like my formula. So I should just be able to hit enter to do the calculation. So icy conditions at 72 miles per hour, right? That was going pretty fast here, remember. Let's drop down the number of decimals. We don't need that many. Let's go to 2 like before. And if I typed it right, I should just be able to fill it down and it should do all the calculations. So let's see. For slick conditions, 0.3 at 72 miles per hour. So I should make a note of that. 72 miles per hour. And usually I don't type that all in one cell, but I'm not using it for a calculation. It's just a reference for me to think about this. So we're moving really fast. It's slick. It takes, oh my gosh, 541 feet to stop. If it's not quite as slick, so maybe this might be light snow at 0.5 and maybe okay tires, 333 feet. 0.7, maybe that's like a rainy day with good tires, 240 feet. Dry day, good tires, good pavement, almost 200 feet to stop at 72 miles per hour. Is what we got there. That was kind of fun. Love spreadsheets. Questions on making a spreadsheet, what these numbers mean?
No, you explained very well, in my opinion.
A little more informative spreadsheet there. All right, so let's see.